My name is Otin Joseph, also known as Uncle Otin. We are going to have a lesson on grade 7 mathematics on probability. And this is the conclusion of probability. In this lesson, we are going to learn independent and mutually exclusive events. Independent events and mutually exclusive events. We have already learned the definitions of these terms. We said that independent events are events whose occurrence do not affect each other. And we also said that mutually exclusive events are any two events whose occurrence affects the occurrence of each other. Okay. Mathematically, we are going to analyze mutually exclusive events and independent events. Now let's take that A and B are any two events. Let's find the probability of A or B occurring if the two are mutually exclusive or independent. So the probability that A or B will occur is given by that. And it should be equal to probability of A occurring or probability of B occurring, or minus the probability of both occurring simultaneously. So this is the probability of A occurring, this is the probability of B occurring, and this is the probability of both occurring together at the same time, okay? So probability of A or probability of B, then minus the probability of A and B occurring together simultaneously gives us the probability of A or B occurring. Okay, and if A and B can occur simultaneously, that is, they can occur together at the same time, then we multiply their probabilities to find the probability that they occur simultaneously. So this is how we calculate for this part and put it into the formula. Now let's consider mutually exclusive events. We said that mutually exclusive events cannot occur simultaneously. They cannot occur together at the same time. For this reason, in the formula for finding the probability of either A occurring or B occurring, we cannot include the probability of A and B occurring together at the same time. So this part will go to 0. That is, probability of A union B will be equal to P of A plus P of B minus P of A intersection B, where this part goes to 0. P of A intersection B goes to 0 because this cannot occur. A and B are mutually exclusive. They cannot occur together at the same time. So let's try out this example. If probability of A is half and the probability of B occurring is 2/5, then we have to calculate the probability that A or B will occur if A and B are two independent events, and B, A and B are mutually exclusive events. So let's take A and analyze the question if A and B are supposed to be independent events. So independent events, I have already said that if the two are independent events, then the probability that A or B occurring, which is written as A union B, is the probability of A plus the probability of B minus the probability of A and B. The probability of A and B is represented as the intersection, and it represents the probability of A and B occurring together at the same time. So we need to find this one, and we know that probability of A and B is equal to the probability of A multiplied by the probability of B, and that is going to be 1/5 multiplied by 2/5, giving us 2/25. So knowing this, we can insert it into our formula, probability of A union B, to get 1/5 plus 2/5 minus 2 over 25. So we are going to get 3 over 5 minus 2 over 25, right? And that gives us this. (13 out of 25). So the probability that A or B will occur has been found to be 13 out of 25. So if the two events are independent, then the probability that one of them will occur or both is 13 out of 25. Let's consider the last situation where we are now taking the events to be mutually exclusive. So we say that for mutually exclusive events, the probability that A or B will occur, written as probability of A union B, is probability of A plus probability of B. Simply because probability of A and B occurring at the same time, which is the intersection, is 0. The two events are mutually exclusive. That is, if one occurs, the other cannot occur. So the two of them cannot occur together at the same time. For that reason, probability of both occurring together at the same time must be 0. Okay, so now we have this, we have that, we can just insert them into the formula, and then off we go. We have 3 out of 5. That if they are mutually exclusive, then the probability of either A will occur or B, but both will not occur, either one of them is occurring, is 3 out of 5. So we have learned probability, starting from the beginning, definitions of terms, the beginning of probability, introduction, laws of probability, the basis of probability, and now we have advanced to a very special aspect of probability, which is mutually exclusive events and independent events. Okay, I know as you progress in your academic ladder, you learn more conditional probability, compound events, and so on. So there are a lot ahead of you to know. But for now, take this. Watch the video over and over again. Try to understand the example and apply your understanding to solve the assignment you came to take from the school's premises. Until we meet again on this media, stay home, stay safe, and take very good care of yourself. My name is Uncle Tin once again. Bye-bye.